Hello and welcome to TidyX episode 79. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
Hey, my name's Patrick Ward. You can find me on Twitter at OSPPatrick, and Tidy Explained is on Twitter at Tidy_explained, or you can Gmail us tidy.explained@gmail.com, or you can open up an issue on the GitHub repo, or you can like and subscribe on the YouTube channel. We would like it if you did that.
Yep, yeah, it lets us know if we're doing a good job or not. We
Yeah.
also appreciate any emails that you want to send to us,
Yep.
letting us know what you think, any new topics you want us to be covering. Right now, we're in a series on Tidymodels. Patrick and I have both not used Tidymodels before, and so we've now started a series going through and taking you through the journey of us learning it and explaining it to you.
Yeah.
So last week, in the last couple of weeks, we've done some very easy or simple model fitting on the linear regression. Last week, we showed how to do preprocessing using Tidymodels. And this week, we're going to continue the process. Patrick, you want to tell them that while I share our screen?
Yep. So we're going to go linear regression one more time here. This time, what we're going to do is we're going to do our typical training and test split of the data. We're going to fit the model to cross-validation folds of the data, and we'll go through that. And then we're going to show how to collect the metrics. Once you fit the model to those folds, you want to summarize the metrics of your model fit. So we're going to go over that, collecting those metrics using the yardstick package, which is part of the Tidymodel suite. And then we're going to select a model from that fit, and we're going to apply it to our testing data, and again, collect metrics and show you the results of both. And then maybe in the subsequent weeks, we'll get into other types of continuous models that we can, tune, and like most machine learning models have little knobs and buttons that we can push and turn up and down. And then we'll go into classification.
Yeah. So, hey, if you also have an interesting data set you want us to be using for this, definitely let us know. We're looking for data sets to be using right now. So just
otherwise we'll keep talking about air quality.
Exactly. But let's get this thing started here. So this is a lot of recap from last week. So we're going to go over it at a really high level to make sure that we're all kind of generally the same page. If you are lost, go check out episode 78, where we go into this more in depth. But this is just setting some knitter options because we're using our markdown to run all our code in here. We've got Tidyverse for our data manipulation needs, Tidymodels, which contains, it's like Tidyverse, where it contains a bunch of other packages that are used for modeling, Patchwork, and for displaying some plots that we looked at, and then Datasets, which contains the data set that we're using, which is air quality. And then we're going to set our theme to be theme light for our plots there, so that they're all consistent and we like the way theme light looks. These are two different plot types that we have here. They're going to show continuous or categorical information against a column that we select against ozone, which is our response variable of our data set. So we set those up. Here we are attaching the air quality data set to our environment, so then it is available. It currently would look as a promise here, but as soon as we call it, it now actually exists as a data set there. I don't know. I always think that's kind of cool. And then, so we're going to take a quick look at this. We're going to convert month into a factor, because before it's a numeric value, and months, in our opinion, are more of a factor as opposed to a actual numeric value. So we're going to create df from that, and it's going to have, if I can scroll all the way up here, month f. No, I guess I could have just taken the head of there. And then we're also going to look across these, and we see that ozone and solar.r have some NA values in there, so we will have to handle those, and we do with our preprocessing. So now we need to go into our data splits. And so we're going to set our seed to 487, just for reproducibility sake. We're going to do a split, and this is something you're always going to be doing with your data. When you get it, you're going to split it proportionally, usually 3/4 train, quarter test, could be thirds, sometimes fifths. And we're going to strata I'm totally spacing on what this word is, Patrick, right now. Stratify.
Stratify.
There we go.
Yeah.
Stratify by month, because we think that's important to make sure that month appears in every split here. And then once we have this, we're going to have our training, our training and our test splits here. And we can pull those out using the training and testing functions so that we end up with the whole data frames, but split out so that we can do whatever we want with them later on. We're going to set up a recipe, and this is the pre-processing that happens to the data. This is the same as what we did last week, where we set a recipe, we write a formula describing what we expect to be occurring. So we're saying ozone is a dependent variable of solar.r, wind, temp, and month f. And the data that it's going to use originally is df train. After we set the dependent and independent and dependent variables, we're going to impute the median for any cases where we have NA values. In this case, we know from looking at it before, it's ozone and solar.r. And then if you take a look at the data sets here, they're at wildly different scales. And so we're going to normalize a couple of the ones that are really large to make them normalized values. And so we've got that recipe then. Patrick added this really cool piece here. Patrick, do you want to go over this?
Yeah, sometimes it helps to just see what that recipe did to the data in terms of pre-processing. So one of the ways you do this is you actually take your recipe and prepare it with the prep function, and then you bake it. So you basically want to run everything over that recipe and then bake it and put it in. So this is useful if you so now you can see everything is standardized with the exception, obviously, of month, F, and ozone. So our dependent variable is on its normal scale. Month is a factor variable, so there's no need to normalize it to anything like that. And then the continuous variables now are all with a mean of 0 and standard deviation of 1. And this is useful because if you ever needed to just yank out the data following pre-processing and store it as its own kind of data set or use it for other reasons, this is where you're going to be able to do that. So we prep the data, we bake it. In the first step, if you just want to see the training data, new data just has to equal null. If you want to see your test data, it's new data equals whatever you've decided to name your test data as. In this case, we've named it df test. So this is the pre-processed data applied to our training and testing splits.
Yep. Then we've got our model, same as last week, where we're going to use a linear regression. We're going to set the engine we're going to be using to the base RLM engine, and we're going to say, hey, we're doing regression. We're not doing classification here, which are two different types of regression that you might want to be doing. And so this is the model that we've got going on here. Mm-hmm. We set up our workflow. So we're going to use the workflow function to initialize. We're going to add the LM model using the add_model function. And then we're going to add the recipe, which is the pre-processing that needs to occur to any data that gets added to it with the add_recipe. And there we go. Now we've got our workflow. It's all prepared. It's all ready. And this is what we did last week. All right. From here on, it's new. 8 minutes in. 9 minutes in.
Yeah.
All right, Patrick, do you want to take us through this?
Yeah, so last week, we basically stopped there. We fit the model on the training set, and then we tested it on the test set, and we were done. This week, we're going to fit the model, except instead of just fitting it on the training set as a whole. Remember, we're dealing with relatively small data here. I think we have 113. If we type df split in the console, we'll see how many observations we've split our data into. 113 observations in this training set. So what we're going to do here is we're going to use this cross-validation approach. So basically what cross-validation is going to do is it's going to take a random sample of our trained data set. It's actually going to take 5 random samples of our trained data set. And each of those random samples, it's going to split the data into another kind of training and test set. So we're basically going to fit the model 5 times over 5 random samples of our training set. And I don't think, did you set the seed before you did that? It is random. So we want to be able to make this replicable. So we set the seed. So now what we have here in these splits are, we have this kind of nested list. And so what we're seeing there, for example, in split 1 is we have from our training set, our 113 observations, we're going to take 90 of them, build a model, and then test it on 23 observations. And then we're going to do that in fold 2. We're going to take those 90 random observations. We're going to test it on 23 of the holdout observations. So each time we're holding out some data, and again, it's random, and there is we can use this, like the same data gets reused. So it's randomly pulled with replacement. So then the next fold, it gets put back. So observation 3 could be in all of those folds potentially. And so we've set this to 5. You could jack the number of folds that you want up to 10, 100, whatever you want. It's a small data set, so we could have done more. It's going to run pretty quick, but we set it on 5. So now we've got our folds ready, and what we have to do is we have to fit a model to each of those folds and then average over the outcomes so that we get an idea of what our error rate is. How good is this model doing on these random folds of data?
And this is something that you might do more often. You have like a more complicated model, maybe that you want to be tuning. This regression is a little bit more straightforward, just to show the concept.
Yeah.
In future episodes, we'll show how you actually use this.
So we're going to go ahead and fit the model. We kind of did this last week, but we used just the fit function like you would in exactly like you would for the regression. This time we're going to take that workflow and we're going to fit resamples, because remember, we have these resampled data cross-validated folds. So the resamples are in the cross-validated folds, and the metrics. So if we left this blank, what Tidymodels would do is it will return the RMSE and the R squared for the models averaged over our 5 folds of data. That's the default. So we just want to show you that you have some options, and there's other measures that you can use. And when we get to classification, we might use other things like AUC and ROC and accuracy and different things. There's a number of different options that you have. Yeah, there you go. So we're going to actually add one to the default. So we're going to keep RMSE and R squared, and we're going to add mean absolute error. So the average of the absolute difference between the ground truth, the observed value, and the predicted value. Okay, so we'll go ahead and we'll fit that workflow through the data.
And so what this is going to do, it's going to run for every fold. It's going to run, train it on the now 1 or 4/5 of the smaller of the training data set, and then give us metrics based on the results of the holdout.
Yep.
And it's going to do that 5 times.
Average over those metrics. And with the collect metrics function, we just arrange it by dot metric because that's the name of the column. So we want to make sure it's always in that alphabetical order. Here we see the average mean absolute error, the average root mean squared error, and the average R squared value, along with their corresponding standard errors. So there we see that root mean squared error. So on average, the model was about 20.6. I don't know what the air quality was measured in, but something. Air qualities. Air quality numbers.
Parts, isn't it? Air
parts per billion or something like that? It's ozone parts per billion or something like that.
ppb.
Yeah, parts per billion.
Parts per billion.
So cool. So we have some results of our model. We have our RMSE and our MAE and our R squared, and now we're ready for the last part of this this little journey here.
Yeah. So maybe you could use this piece though to just kind of generally assess how your model's doing, and maybe decide if you want to try a different type of model. If you're like, whoa, I really need to be better than this. Correct. Or you could do this. You're like, awesome. This is exactly where I was hoping I would be. This gets me enough information to be able to actually do my job.
Or, which maybe we'll do in subsequent videos, is you might fit several different models, in which case you might row bind these things together and then be able to compare the models in terms of their success at minimizing the error between the predicted value and the observed or the ground truth value.
Alrighty.
All right. So now we're all set with that. We fit the model and we're ready to yank out that model. We're happy with where it's at. We're going to yank it out and we're going to apply it to the testing set. So the first thing that we need to do is we need to get that model out. There's a few options here. If this was a model like we will do in the future where you have to tune things and you're looking at tuning parameters, we might use a best fit option. In this case, since it's linear regression, we use cross-validation. There was nothing to tune. We're just going to choose the last fit. So the last fit model from that, from what we had there, the coefficients from that last fit, that's what we're going with. We're going to put the workflow in there. We're going to say split. So this is important here, right? Because split is basically, remember, that's where we created the initial split of the data all the way up in the second chunk. So there we have our 113 training data set, training observations, and our 40 testing observations. So we're going to say we want to take that last fit, put the workflow in there so we pre-process the data respectively, split the data, and then set the model to our training set, and then set the model to our testing set, and then yank out those same metrics, and let's take a look at those on that testing set. So we'll go ahead and do that.
There we go.
And now we have the fit LM, and we're collecting the metrics on that testing set. So now what we have is, you can see if we run the, that one, yeah.
So keep in mind that this top one is the data set that has been trained on the full training data set. And these metrics are comparing that against the test data set, which I hasn't seen. Or in this bottom one is the training data set with the averaged cross-fold validation.
Yep. And so what is common, what you would normally see is when the model is built on its training data, you tend to get very overconfident and happy about it. And then once you apply it to new data that it hasn't seen or data that hasn't been used to fit the model, it gets worse. And that's what we see here. So we see the mean absolute error goes from 16.1 up to 16.7. We see that the root mean squared error goes from 20.6 up to 24.9 parts per billion. And then our R squared of the model goes from 0.473 down to 0.468. So in R squared, higher or closer to 1 is better, right? Because it's saying that the model is explaining a higher percentage of the variability that we see in the dependent variable. So in this case, it got a little bit worse. And we're aware of that because that's common and that's how these things work.
That's exactly what you'd expect.
That's why they call it a model. If it was 100% accurate, they would just call it reality.
Yeah, exactly. And this is just kind of for assessing your models. This is like a high level introduction to that combined with the cross-validation. So I think with that, I think that's everything that we wanted to cover in this week's installment of Tidymodels with TidyX. Thank you all for joining us. If you like what we're doing here, please subscribe, please like, please leave a comment. We really appreciate it. We appreciate the feedback here. And as always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick and Tidy Explained on Twitter at Tidy_Explained.
All right. Thank you all so much and keep on exploring your world.